I'm Frédéric Berger, and with the team today we are going to present the result of the preparatory work on Simpl. First, let's meet the team that is in this room and online, and that will present the project result. This morning we are going to go over the requirements and the architecture, and we'll be happy to meet you during the break in case you have also more questions. So project context. So this project is born from the ambition of Europe to become a leader in a data-driven society. And in such a society, European businesses and public sector need to have access to resilient and competitive data storage and data processing capacity. Therefore, the European Union is taking action to enable the deployment of European data spaces, and in particular to, let's say, produce Simpl, which is a middleware platform that will support the creation and the federation of data spaces. This Simpl will be open source, as we mentioned, multi-vendor, and it will be modular and interoperable. So in this context, the project look at Simpl and define the requirements and a high-level architecture vision for the implementation, or let's say the elaboration of a minimum viable product, MVP, of Simpl. That was the first objective. The second objective was to define an implementation roadmap for the realization of the European middleware platform vision. I'm going to walk you over the approach that we followed for this project. The first phase looked at the business requirements. So we start with analyzing the business case. We looked at the business requirement, architecture requirements, and defined high-level business processes. All this was used to define the architecture vision based on architecture principles that were shaped for this project. The technical requirements during the first phase, we start with a market analysis to look at what are the vendor solutions available on the market, what are the reusable building blocks that could be leveraged for the creation of Simpl, and we took that to define an information system architecture as well as a technology architecture. We also looked very importantly at the lifecycle requirement and the overall governance for such an initiative. We also looked at the service level requirements. The last phase looked at the dependencies and the activities for building the implementation roadmap. And we then build a cost model to define and estimate the cost of such an initiative. This was used in the end, all this work also to elaborate recommendation on, let's say, the future implementation of Simpl. But before we diving into the requirements and the architecture, let's define or let's look at what is a data space in simple terms. And a data space is basically an ecosystem of trust partners. Trust partners who have defined common standards and rules to store and share data. In a data space, the data are not centralized. They are provided by data providers when necessary. And a data provider can participate to several data spaces at the same time, meaning the data spaces, they can overlap and be nested. So with this, I will hand over to Adrian for the presentation of the requirement. Thank you.
It's okay. Thank you, Frederik. All right, so as a first step, we started with the identification of the requirements for the Simpl platform. We did an analysis and defined business requirements, service level requirements, and product delivery lifecycle requirements. This was done by conducting interviews with various stakeholders. Those were interviews, workshops, where we discussed the use cases and that data spaces that were already existing, already active, or in preparation phase. We talked to all those people. The data spaces and organizations that we talked to were both directly connected to DG Connect, but also private industry players as well that are working in this space. So business requirements, well, those describe the behavior expectations and functionalities of the solution. An example of that is, let's say, the middleware shall enable infrastructure providers to provide storage services and access through the SMP. That's an example of a high-level business requirement. The service level requirements, those specify the qualities that must be exhibited by the smart middleware platform. An example of that is the SMP shall provide end-to-end integrity of the data that is delivered or exchanged through the platform. Product delivery lifecycle requirements talk about how the middleware platform will evolve from its inception to the maintenance and the evolution. An example there is the common issues that might occur are resolved through a well-defined process and without any or too much human intervention of support staff. Finally, we have the information system and technology requirements. Those describe the interactions and the flows between the various building blocks of the architecture and the underlying technology that supports it. For example, we created, we created Archimate diagrams that present all the building blocks and how these interact with each other. Next, also from all these discussions, we were able to identify the goals of the Simpl platform. The main goal is to federate data, software, and infrastructure across the entire European Union. And also to enable to foster collaboration between various parties, public sector, private sector, within and across industries. It allows all the stakeholders to pool together resources, be it data or infrastructure or applications, to create business value and increase the efficiency of any resources that are being used. As I mentioned already, we have stakeholders of both public sector and private sector and research institutions that can all work together on the same platform. An example is that could be simplified by Simpl is collecting and combining data from various sources and to support decision-making in a data-driven government. All right. From that, we then defined 10 guiding principles for the entire architecture. I will not go into each of those, that's a lot, but I'll pick a few. First of all, the federation part. So the SMP will federate both data and infrastructure and be interoperable and have a decentralized setup. It will define standards and frameworks that all participants need to implement, but still allow for full autonomy of all participants in the data space and those using the smart middleware platform. As already mentioned, it's open source, but it will also use open source existing, even open source components. And those components can, in certain cases, be deployed only a part of the functionality. Not all users will need all functionality of the platform. So it's very modular, and there's a loose coupling between all the components. So if one component changes, it does not affect the other components of the platform. It's very open, already mentioned before. It's open source, but it's also open source on the level of the documentation, design decisions, all of that is open, so it allows for full insight into the architecture. There are no proprietary claims, also mentioned already, it will be open source, but also the components that are being used should not have a strict license that does not allow for an open source implementation. Security is privacy and trust, very, very important, obviously. The requirement of the principle is that the SMP Smart Middleware platform must provide a secure and trustworthy environment while still complying with all the relevant regulations of the EU. It should guarantee the data confidentiality and integrity, and assure the privacy of both the data subjects, could be people of the European Union, and the end users of the platform. The final one is that I will mention is resilience. The entire architecture should be fault tolerant, so that any failures have minimal impact on the full deployment. This will be done by making sure that there are no single points of failure and by the distributed architecture of the platform. All right, so a bit more technical already. The architecture vision of the Simpl, the smart middleware platform. The idea is that the smart middleware will be used to set up a data space where various actors can interact with each other. You can see here that we have a data provider, infrastructure provider, application provider, end user. Those are all actors that are working together in a data space. Data providers, they have assets. Data assets might be valuable, might be want to be monetized. Infrastructure providers have the computer infrastructure available, and they want to increase the usage of that. And finally, the application providers, they have applications, but could also be algorithms or machine learning models. Those are all applications that can be used through the Simpl platform. Finally, the end user. The end user is not an individual person, but rather an organization that is consuming data of the, that is exposed in the smart middleware platform. Consuming data, consuming applications, or consuming infrastructure that is provided. And finally, it's important to mention that each of the participants can assume multiple roles. So it's not that you can only be an end user or an infrastructure provider. For example, let's say a university could provide some data and also be the end user to do some analysis on data by themselves or from other parties. It's also very important to know, as you see here, that the Simpl platform does not mean to only work or describe or define one single data space, but also allow interoperability between multiple data spaces. Its example here is the mobility data space, which can contain all data around mobility, and there's smart cities, another data space, more governmental, that they might want to collaborate to gain new insights. Final remark, the data space is specific functionality. So the smart middleware platform is generic. So there could be specifics to a specific data space, and that is outside of the scope of the smart middleware. So the data spaces can still define their own specific requirements, and this smart middleware platform is agnostic to that. All right. Next up, again, more in depth. How does all of this work? How do we organize this? Each of the participants that will work together in a data space that is being managed by the smart middleware platform will need to install an SMP agent in their infrastructure. What is it? It's a piece of software that enables participation in a data space or also across the other data spaces that I already mentioned. it's only one deployment that needs to be done per participant. And the reason is, the goal is to make sure that data is exchanged directly between all participants in a data space. So there's no central gateway needed to exchange data. The communication is direct, which avoids any network bottlenecks if there would be one central gateway. So each actor installs that, and it's actually sort of an abstraction of the internal systems that are behind that stakeholder. Also, the deployment of that agent can vary in granularity. Could be a single organization, small organization that just wants to consume data or consume infrastructure to the middleware platform, or a bigger data space that already exists. For example, the energy providers, energy producers, network operators, they already share data as a goal to minimize grid failure. They have collaboration already in place, but they also want to share parts or all of their data to a data space, to the smart middleware data space, so they can integrate on another level to form, for example, the EU energy data space. Okay, more in depth. This is the conceptual architecture of the Simpl smart middleware platform. We organized all the features in a few blocks that contain the same related services. Let's start with the data services. The data services block provides a functionality to share data and applications between the participants that use the smart middleware platform. We have the infrastructure connector services. Those connect to the internal infrastructure that I mentioned of the participant that is related to infrastructure. It's important to know that this does not provide the infrastructure itself. It only connects to it and allows that infrastructure to be opened up to participants of the data space or of other data spaces. We have the administration services part. These are all the services that it needed to allow the platform to run, the smart middleware platform to run. Jochen will go into much more detail on each of those components. But you need, for example, access control, any reporting, and also the federation management, being able to federate within a data space and across data spaces. Finally, you have the governance part, which is sort of a more technical governance, not really organizational. It is there to ensure the contingency in case of any technical issues and respond to any security threats that might occur. So it does the computer security incident response team. Final thing to remark is that we have, at the bottom, you see we have user services and supporting services. User services are mostly services that are used directly by the end users of the smart middleware platform. The supporting services are behind that and are being used by the user services. So that's the part I want to talk about. And next is Jochen, who will go into more detail.
Right. Thank you, Adriaan. Yes, thank you. And good morning to everyone in the room, and good morning to everyone online. I see we have an abundant audience online as well, which I'm happy to see, of course. So indeed, Adriaan has already told you, I will continue with zooming in on the architecture and zoom in on each of the specific blocks a bit more, but we'll try to keep it at a high enough level that it becomes not too much technical details. So the data layer. As Adriaan told me, the real, let's say, goal of this layer is to share data and share applications as well. So we take applications a bit similar to data because, well, they are related. Applications, in essence, it's data that can be executed by a computer. But there are, of course, differences, so we shouldn't completely consider them the same. So we do consider them as separate capabilities, but they both are part of the data services layer. So we have the application sharing capability, which is there, of course, to enable the sharing of applications between participants. And then we distinguish several types of applications that can be shared. It can be solely, let's say, algorithms or machine learning models, but it can also be full application software, full apps and executables. And then we have next to that the data sharing capability, which does a similar thing for data. So this is purely data, where we also distinguish different types of data. These can be simple data transfer, bulk data transfer, or even real-time data streaming, although it's something will be coming in the future. And of course, these things have to be discoverable. You have nothing if you have data available if you can't discover it. So for both application and data, we have discovery services that make sure that you can search a certain catalog, and then you can find the applications or data that's available to you through the platform and through the data space. Then below that, we also have some tooling, so data processing tooling. If you're familiar with the digital work program, you will see that in the smart middleware, there is the requirement to have basic data processing tooling within the platform itself. This is really embedded in the platform, and this allows actually users to be able to execute simple data processing algorithms at the edge. So rather than really have to transfer the servers, the data from a data provider to an end user, the end user can also use this internal tooling to do some data processing at the source site, let's say, and only export the results back to him, which allows a bit more data sovereignty. And then we also have data governance. So this is really all about managing the data lifecycle and kind of have some sort of quality control on the data assets that are being used. On the supporting services, so these run a bit more in the background, let's say. We have the data orchestration and the distributed execution management. So this is really to orchestrate several data assets and make sure that everything works smoothly together. Then on the infrastructure services, so this is rather different approach on this layer because, well, we don't really focus on doing the infrastructure orchestration ourselves. There's plenty of good software available to do this. I'm thinking of Kubernetes and all the other containerization orchestrators. So it's not our goal to replace these orchestrators within the middleware. It's really our goal to connect to this existing software. So when you see as well, all the way at the bottom, you have the legend, which has access through or built in. Most of these services are accessed through. So through the middleware, we'll access containerization services, VM, virtual machine provisioning services, and then we can open up this infrastructure from an infrastructure provider towards an end user without having to redo the entire work on orchestrating infrastructure because it's complex and these things already exist, of course. But within these access to services, we distinguish several different kind of services. So we have really the core cloud and edge computing, which is virtual machines, containers, serverless, and storage provisioning. We also have a small box on high performance computing, which is something separate. It has specific requirements, hence we consider it as a separate box. And then we have the high level platform as a service services. So this is not really an exhaustive list. You can imagine many other different platform as a service services, but we listed some examples like SQL databases, NoSQL databases, time series databases, blockchain infrastructure, or even messaging buses. But again, this is not really an exhaustive list, and you can really think of other platform as a service services that can be embedded. Well, it depends a bit on how the idea of the Simpl platform evolves. Of course, all of this has to be discoverable as well. So for that, we have also the discovery capability, which will list the infrastructure services. Also has a common metadata description for all these services that users can go to the catalog, find what services are required for them, find, for example, the conditions that apply to them, and be able to use those infrastructure services. Again, on the supporting infrastructure services, it's infrastructure orchestration and distributed execution management to manage and orchestrate different infrastructure providers at the same time. Then on the administration layer, so this layer really is there to support the core functionality of sharing data, applications, and infrastructure. And it's a lot, let's say. This is a big layer with a lot of different functionalities to really make sure this entire platform becomes a good product that can be used in different contexts and that works well, is secure, is trusted by all users. So we have the federation management, which is a bit of a complex name to say that it manages the different federation that's going on. It manages how different sources are connected. And a typical thing that's put in this box is, let's say, the configuration of different sources and the configuration of the trust you have in different providers, for example. So it's a generic box to really make it all one big glue. Of course, we have security. We need encryption of the communication. We need encryption of data at rest as well. We need encryption of the data that's collected within the platform itself as well to make sure that everything is private and secure. And we need integrity on all these data as well to make sure that it's not been changed throughout the lifecycle, of course. Then on the network, you might need a VPN or you might need an additional firewall, depends a bit on how you deploy your SMP agent FUC. You can deploy it behind your own firewall, or you can maybe use the firewall that is embedded in the platform. Of course, we need audit. Traceability is very important, especially when it comes to, I think Pierre already discussed this, the maybe monetizing certain assets. Then audit becomes important as well, so that there is a clear, immutable audit layer that shows, okay, this is what happened. So there's no dispute afterwards on the billing, for example. So this is very important, and this audit logging should be immutable as much as possible, of course. And then we have access control and trust, which is a very big box. So this is really everything about identification, authentication, and authorization of different providers. So I think we do have the time, so I will go into more details on those things later on as well. But the goal of this box is really to identify different providers and different end users as an organization and authorize each other to certain data assets, infrastructure assets, or application assets. But like I said, I will go in a bit more detail after these slides. Then we have contracts. So especially when it comes to monetization, again, you're really talking about business transactions. These usually come with contracts as well. And the contracts box is not there to fully replace the, let's say, contractual agreements that then are happening in the real world, but really to facilitate the signing and agreements that happen between parties. For example, if a certain data assets cost money, there's also a service level agreement linked to it usually, because as a consumer, you want some certain service level that the provider agrees to. And all of this is part of this contracts box with usage contracts, billing, and license asset management. Then, because of course it's a platform and a usable product, you also want monitoring and you want reporting on those monitoring, which is then the last two boxes you see on this administration layer. So monitoring, we have identified several key KPIs to monitor, which can be data usage, usage quality, application usage. Also the energy metrics, which is quite important to see the footprint of your work and the footprint of your what you're doing with the smart middleware platform. And this fits well within the Green Deal ambitions of the European Commission, of course, to really have a good view on this and also be able to optimize for these metrics. And linked to most of these KPIs is, of course, the reporting on all these different metrics and how you are performing as a user of the platform. On the last layer, we have the governance. Like Adriano already told you, it's mostly technical governance, so real details on the entire governance of the data spaces will come later, presented by Sebastian, I think, and you will get all details. But in this, we usually talk about the support for the platform, which is like a support page, a ticketing system, and a help desk if necessary. And also active monitoring of the security incidents and how to respond to them, because it's a platform provided by the Commission. They're also actively monitoring certain attacks or incidents that happen towards the platform and make sure that everything works as it should and that vulnerabilities are fixed whenever they arise and are discovered. On to the next slide, which is the system architecture, but I'm going to drink first. Okay, thank you for your patience. So now we really map all these capabilities that you've seen to system components. So what Adrian showed before was more of a, let's say, a symbolic way of showing it without all the different details. But when we start really mapping the capabilities to actual system components, so let's say servers on somewhere, let's not specify where they are, we see that we we started really from the idea that we want to distribute as much as possible. It should be really a decentralized platform in its core. Unfortunately, or let's say throughout the design, we realized that some services do need to be centralized to just make it feasible or at least manageable to really deploy them within a data space. So these then we call the centralized services. And we identified 3 centralized services, which is the discovery services, the vocabulary provider, and the identity authorities. So I'll go in detail what these are. So the discovery services, as the name suggests as well, this is to discover data infrastructure and application services, of course. And these maintain the catalog that you saw before in the capabilities of the data discovery, infrastructure discovery, and application discovery capabilities. So this is where the catalog is maintained, and then users can query this catalog, find the data assets that they might use or other assets that they might want to use, and where and how to connect to the providers that offer them, of course. Well, we talk about centralized services in the data space, but it doesn't have to be one single catalog for the entire data space. You can have a couple, let's say, but the idea is that then they're paired together and they are cooperating together to form a unified picture of the entire catalog per data space. The vocabulary providers, those in the audience who are familiar with the IDSA architecture will probably recognize this. So this is indeed has the same functionality. It distributes the vocabulary or the metadata descriptions, for example, that are used in the data space. So if the data space governance at some point decides to update the way some data is represented, this vocabulary provider will distribute this new representation towards all the participants of that data space. And then lastly, which is quite an important part here as well, is the identity authority. So again, onto the identification and authorization of the entire platform. This identity authority will really deliver all the identities that are used in the data space to connect to each other and be able to trust each other. But like I said, I will give a bit more details on that in the next slides as well, which are now actually. So let's say the identification, authentication, authorization, it's really important for the platform. So we really deep dived into that topic specifically because we feel like it's important to trust each other, and that's really the basis of becoming interoperable. If you don't have this, well, you don't really have a platform. You can just share data over the internet publicly, but that's not really the way we want to do this. So we really deep dived into this IAA topic to make sure that we have some options available for later that work and that we're quite, let's say, sure of that are secure enough for this platform. But the entire topic is quite complex. If you have to authenticate within the platform every single individual end user, it becomes rather difficult to scale, let's say. If every user has his own file to manage, for example, identity file to manage, it becomes extremely difficult to scale this and to manage all these identities. So what we took is, what we decided on is a 2-tier approach to this identification and authentication, where the individual, let's say, physical persons are first identified within their organization to the SMP agent. And then the SMP agent and the organization as a whole is identified and authenticated within the data space. So for this first step, you can have your local authentication mechanism. It can be connection with eIDAS, can be Microsoft single sign-on, OpenID, whatever that is fit for your organization, of course, and you authenticate the end user that use your SMP agents. And this then maps also to the user roles capability you see there below. And then this SMP agent, that's the let's say, component that receives the digital identity that is recognized within the data space. So within the data space, you then use machine-to-machine authentication between different SMP agents to authenticate certain organizations to certain data assets. So the goal for a data provider, for example, it can also be an application provider or an infrastructure provider, is to authorize other organizations based on certain attributes, identity attributes. What these attributes are really depend a bit on the data space as well and certain specifics of the data space. And I can imagine, for example, that the smart cities data space might want to authorize other other cities, which then it's an attribute, the city that you're in. But for example, the energy data space might be completely different. So the specific attributes of the identity file, we haven't specified that because it really depends on the content of the data space and the topic of the data space. But let's just think of that we need some custom attributes to identify each other and authorize each other based on those attributes. And then, of course, where does this identity file come from? Well, it comes from the identity authority. So that's the real purpose of the identity authority, is to give these identity files to participants, as well as authorize that these are the valid files. And depending a bit on the sort of mechanism you design on for identification, that process is a bit different, but the report details on all those technical details, but I'm not going to go into that today because I think it's a bit too much for now. What is important though is how do you then federate these identities across different data spaces? Because we want these data spaces to be interoperable. We don't want to build closed ecosystems on a specific topic that are then not be able to talk to each other and not understand each other. So it's really important to also federate these identities across these data spaces. How this is done, again, depends a bit on the type of identification mechanism you choose, let's say. We've investigated 3 possible identification systems. Each of them we detail how federation will be done, but let's say the usual thing to do is to have a list of trusted identity providers at the root of each data space. And these can then trust other data spaces through importing, let's say, the trusted identity provider on their list that is then distributed across all the participants of the data space. Again, it's quite technical, and I don't want to go into too much detail on this. If you have any questions, do feel free to ask, of course, and I'll try to answer them to my best of my ability. But the idea is to really trust each other's identities of a data space so that you can communicate with each other and understand each other and really start to exchange data between sectors and not just within your own sector or topic. I see that I'm running on, not really out of time, but I'm really ahead of time. That's good. That's a longer Q&A. The last thing we investigate is the information and system and technology requirements. This also came into one of Adrian's slides. So these are not really requirements as a list of requirements like you would expect, for example, for business requirements. But what we did is we wanted to show how the information flows between all these building blocks we've discussed and what technology are behind it to support these capabilities as well. And we did that by 3 different diagrams. We have context diagrams, information system Archimate diagrams, and technology Archimate diagrams. I don't know who's, let's say, familiar with the Archimate language, but it's a sort of architecture design modeling language that's common understood and that is able to show the different interactions that happen between architectural building blocks. So our approach to this task is we took 7, let's say, high coverage use cases of the platform, and then we mapped each of these use cases to these different diagrams, starting from a context diagram that shows the main capabilities and actors that are involved in a certain use case, then to the information system requirements, where we really talk about how the information flows between application components and how this is linked to the business layer above. And then on technology requirements, we really try to deep dive a bit because we can't be too specific yet on the sort of technology that supports this. This can be databases, different server nodes, for example, that support this capability as well.